This is the last section. This is section 5 of our unit on forces in motion. Section 5 is about gravity. The important terms that you're going to need for this section are gravity, weight, projectile, centripetal acceleration, and centripetal force. And I am actually going to have pieces from this put into the notes as we go along so that you can check to make sure that you're getting your notes in the correct order. Okay, here we go. First thing, our question is, what causes the path of a projectile to be curved? And the definition of gravity, the attractive force between any two objects. Gravity depends on the mass and distance between objects. So the more massive two objects are, the more gravity is going to be attracting them. So the mass of these two objects compared with the masses of these two objects, this one is heavier than my pen, so the gravity between them is going to be bigger. If I hold these close together, the gravity between them is bigger than if I hold them further apart. The gravity decreases the farther that they go. So then the gravity between the sun and the earth is very, very large, and then so is the gravity between Earth and the moon. And the Earth and the moon are actually a lot closer, and so that also affects how much gravity is acting between us. There's actually still more gravity between Earth and sun because they're so much bigger. The sun is so much bigger than the moon, so that closer distance is not enough to make that the gravity between Earth and sun. Okay, so the next thing that we're going to write down is weight. And weight is the gravitational force exerted on an object. And I like to call it the force due to gravity. So we know that gravity is what pulls everything down. That's the acceleration due to gravity. And your weight is how much force you're going to exert on whatever you're standing or sitting on based on that acceleration. So weight is actually a type of force. It is the force due to gravity. So that's where this symbol Fg comes from. So you're going to put down the definition for weight, Fg, the gravitational force exerted on an object, also known as force due to gravity. And the equation for this is actually Fg equals mg. So Fg equals mg. So this should look very similar to the equation for force, which is just ma, mass times acceleration. This is a specific type of force, Fg, and it's going to use a specific acceleration, which is known as g, the acceleration due to gravity. Now this is a constant that's different on every planet or every moon or whatever surface your object is on. Here on Earth, that value is 9.8 meters per second squared. On Venus, 8.9 meters per second squared. Mars, which is quite a bit smaller than the Earth, that is 3.7 meters per second squared. And Neptune, which is quite a bit larger than the Earth, it's actually larger. It's 11 meters per second squared. So if you look at these, you could predict already what the different force sizes, the different weights are going to be on these different planets. Which one is going to be the heaviest? Where are you going to be the heaviest? And where would you be the lightest? So just looking at these numbers, you should be able to predict where you're going to be the heaviest and where you're going to be the lightest. Then what we're going to do next is actually calculate that. So this says, planets in our solar system have different masses and different diameters. Therefore, each planet has its own unique value for g. That's acceleration due to gravity. Find the weight of a 58 kilogram person on the following planets. So I've wrote out my work here. So we're going to do this, and you're going to calculate for each of those what the weight would be in newtons on each of those planets. So for each one, we're going to use the same mass. The mass is 58 kilograms each time, and then we'll just multiply times the different values of g, which are given over here. 9.8, 8.9, 3.7, and 11. So go ahead and calculate all of those, and then you can check your answers with mine on the next slide. Okay, so for the first one, I got 568.4 newtons, which I'm going to round off because there's only two numbers in each of these. I'm going to round that off to only two numbers with a 0. That's going to be 570 newtons. 58 times 8.9, that was 516.2. I'm going to round that off to 520. 58 times 3.7, 214.6, so that's 210 newtons, rounded off to two significant figures or two non-zero numbers. And then 58 times 11 is 638, so I'm rounding that off to 640. So did your predictions work out? Did the one that you thought was going to have the biggest weight actually turn out to be the biggest weight? So Neptune should have been your choice for biggest weight, and Mars should have been your choice for smallest weight, which is what we found here. Okay, the next thing that we're going to talk about is projectile motion. So a projectile is anything that is thrown or launched through the air, and it usually follows, well, always follows, some kind of a curved parabolic motion. And if it's launched upwards first, then it's going to have this nice upward arc. If you just toss something, it's still, notice how it still goes down even though I'm launching it sideways. So this shows a diagram if somebody throws a basketball straight out and the direction of the basketball is out and also down. So it's moving forward at a constant speed, but it's also accelerating downward, which is why you get this nice curve that happens. It's going forward faster at first, and then it increases speed as it's going down, so it's covering more distance as it goes down then. Now, if an object goes fast enough, if you throw it fast enough, you can actually throw it so it goes all the way around the Earth. And that's what orbit means. Orbit is when something is going fast enough that it keeps missing the ground. So you can see this person threw it and it got, a little bit further and then a little more further and a little further. And then finally it goes far enough that it's falling basically at the same rate that the Earth is curving, so it can go all the way around. Now, that's really, really, really fast. On Earth, the magic speed to get into orbit is 17,672 miles per hour. So when you learn about the space shuttles that used to orbit Earth, and now satellites that orbit Earth and the International Space Station, this is the speed that they're going. And sometimes they'll have to fire some engines to build their speed back up. They start losing some speed, and so they'll start losing altitude and they'll start to come back down. So they need to fire their jets to get their speeds back up to this magic number again so that they don't fall. Okay. So we should have a projectile is anything that is shot or thrown through the air. And then these two pieces, a projectile follows a curved path because it has both horizontal and vertical motion. Vertical is V-E-R-T-I-C-A-L motion. If an object is fast enough, it will miss the ground and go into orbit. On Earth, this speed is 17,672 miles per hour. So that's what you need to have written for the last slide there. Next slide. Centripetal acceleration and centripetal force. So centripetal is actually a Latin term for center seeking. So the first part of the word centri, that means center, and petal actually means seeking, so this means center seeking. Centripetal acceleration is an acceleration towards the center of a circular path. And then centripetal force is the force that's acting towards the center of a curved or circular path. So now I'm going to show you a few examples, and I do want you to draw all three of the examples. Here we go. So for centripetal force, we're going to look at these three examples here. So these are different curved paths. So on a roller coaster, when you do a loop upside down, the centripetal force is gravity right at the top there. As it starts in right here, what's pushing it towards the center is actually the track. And then once it gets all the way to the top up here, gravity is what's pushing it in towards the center. And then as it comes back down, it becomes the track again. On the curved road here, that's the friction between the tires in your road. When we had some more slick roads in the winter, it's hard to negotiate or to get all the way through a curve if you don't have enough friction between your tires and the ground. If it's too slick, you can just slide and go straight instead of actually being able to go in the curve. And so that centripetal force is actually the friction there that allows you to push towards the center of that circle. The last example that I have is an object that's on a string. So if you have something on a string and you swing it above your head, like a lasso maybe, or a yo-yo or something, the centripetal force, what's pulling it towards the center of that circle, is the string itself. So the tension in that string is what's the centripetal force. So these are just some more types of forces that cause different types of accelerations. So two forces that we discussed today were gravitational force, which is determined by the acceleration due to gravity, and also centripetal force, which is determined by the centripetal acceleration. Okay, so here are a few more examples. Have you guys ever seen the example where if you have a pail of water and you spin it really fast, you can keep the water inside? So we can talk about why that water stays inside next time. There's this big formula for centripetal force. You don't need that formula. That formula is a big complicated mess, and we're not going to mess with it. So our summary. Gravity is the attractive force between any two objects. It's not just planets and people. It's any object. It's just that, like, between my calculator and my pen, gravity is so small that it, it doesn't really affect anything. We don't really see the effects of gravity until things get to be like the size of planets. Really, really big. Now, weight is the gravitational force acting on any object. It's perpendicular to the ground. It's always straight down into the ground. So weight is a type of force. So it's going to be measured in newtons. Usually we measure force in pounds. We measure our weight in pounds, but the unit for force that we're going to be using in science is the Newton. Projectile is anything that's launched through the air, and it always has a curved path. Centripetal acceleration is an acceleration towards the center of a curved path, and centripetal force is a force that's acting towards the center of a curved path. And in a couple of our examples, we saw that gravity actually can be the source of that centripetal force. Not always, but it can be. Okay, that's all of the notes for motion and forces.